Hi there. In this lesson, we're going to look at real numbers. Now, we've dealt with these real numbers in the past, but I've probably not brought up that name. Let me build up what's called the real numbers. Let's start here with 0. And then let's add to that 0 the counting numbers like 1, 2, 3, and so forth. And I'll put little dots at the end here representing that they go on forever. Now, let's take and put some negative signs in front of the counting numbers and put those on the left-hand side. And this whole thing makes a set of what's called the integers. So the integers contain the whole numbers, which is a 0, and the counting numbers. And then the integers also include the negative numbers. And this whole set are called integers. Now, let's look in between, let's sort of magnify in between two of these integers. Let's say between 0 and 1. And what you might see is some fractions. Now, let's look at this. We have, like between 0 and 1, we have 1/5, 1/2, 2/3. Those are some fractions that can fall between 0 and 1. And those fractions are made up of integers. And, oops, I got a duck. Fractions are made up of integers, and the denominators cannot be 0. Now, there's some other properties here that we have to look at for what's called rational numbers here. These include the fractions and integers. Is that, let's take 1/2. You divide 2 into 1, you get 0.5. It's a terminating decimal. If you take the, let's say, 2/3 and divide 3 into 2, you get a repeating decimal. If that happens, then you have what's called a rational number. So the rational numbers are these integers and fractions between them. Now, there's one other thing we have to cover here as far as real numbers is concerned, and that's what's called irrational numbers. And they are a part of real numbers. And Hilbert here is going to help us out here. Let's look at this symbol. Means pi. And it stands for 3.1416, and it goes on forever, and it doesn't repeat itself. I mean, it doesn't start repeating itself. The square root of 2 is a similar example. It goes 1.414, and then it doesn't start repeating itself. These are non-repeating decimals. If that's the case, I got to get out of the way again. If that's the case, then what we have are irrational numbers. Now let's take a look at the entire picture here of the real numbers. And here comes Euclid here with a diagram to help us out. So the real numbers contain the rational numbers, which are the integers, the whole numbers, and then we have the irrational numbers like our pi and the square root 2 here. Thank you.